Now, my dear children, we go to the next topic, that is the concept of electrons and holes in semiconductor. Okay. Now, this topic actually lead to the current conduction takes place in semiconductors, because semiconductor are also a device, okay, substances which can conduct electricity. Okay, but this conduction of electricity is not only due to the electrons, the flow of electrons, but it's also due to the another charge carrier that we learn now, that is called holes. Okay, that's why electrons and hole, this is the concept of electron and holes in semiconductors. The children, you know that semiconductors are the material. They are the material whose electrical conductivity that lies between what? High conductivity of metal and very low conductivity of what? Insulator. Okay, and they have an energy gap, and that energy gap in semiconductor, as you have learned in the last YouTube video also, is less than 3 electron volt. Okay, now for germanium and silicon, you learn for germanium this energy gap is almost 0.7 electron volt, and for silicon almost 1.1 electron volt. Now this semiconductor is also provided by the band called conduction band, and what band? Valence band. So let me just draw again the similar way. This is a conduction band, and there is a band which is just below the conduction band, that is called what band? A valence band. Valence what? Band. The valence band is completely filled, where conduction band is empty. But usually what happens at conduction band, this is conduction band, this is conduction band, okay, and this is which band? A valence band. So we write in short form also as BB. Now approximately, if I take a semiconductor like germanium and silicon, your energy gap is approximately 1 electron volt. How much electron volt? 1 electron volt. Okay. So what happened for this semiconductor like silicon and germanium at room temperature, some of the valence electron which are present in this valence band acquire some extra additional energy, and this energy are called thermal energy, but this energy will be greater than this energy gap. Like for silicon it is 1.1 electron volt, or for germanium it is 0.7 electron volt. That means on an average, if we see the energy which acquired by the valence electron in the valence band will be greater than 1 electron volt, which is more than this energy gap. So that due to this energy acquired by this electron in the valence band, they cross into the which band? Conduction band. That means 1 electron from valence band goes to the conduction band. So one of the electron will be in the which band? Conduction band. As soon as there is a electron goes from valence band to conduction band, a vacancy is created. A vacancy will be created in the valence band at each place where the electron were present before moving to the which band? Conduction band. So if one electron moved from valence band to conduction band, one vacancy will be created. Similarly, another electron moved from valence band to conduction band. Suppose this is the electron move from valence to conduction band, one vacancy will be created. So one space, empty space will be created. Similarly, whatever number of electrons move from valence band to conduction band, that much number of vacancy will be created in the which band? Valence band. So just showing in the diagram, you see like there are number of electrons which are moving from valence band to what band? Conduction band. Like 1, 2, 3, 4, 5 electrons has been moved from valence band to conduction band. Means how many vacancy has created? 5 vacancy has created in the valence band. Now these are the electrons. These are the electrons in the which band? Conduction band. But this movement of electron from valence band to conduction band makes a vacancy to create in the valence band. So as I said already, a vacancy will be created in the valence band, that you can even see in the diagram, and this vacancy are nothing but the holes. Okay, so a vacancy is created in the valence band at each place where an electron was present before moving to the conduction band, and this vacancy is actually called as hole, because the absence of negative charge at any place is equivalent to the presence of what? Equal positive charge, as for the conservation of charge is concerned. That's why this hole is actually a seat of what charge? Positive charge of equal magnitude to the charge of one what? Electron. Charge of one what? Electron. That's why in semiconductor, whenever number of electrons move from valence band to conduction band, equal number of holes that will be created in the valence band. Okay. So this hole and electrons now conduct the electricity. That means they conduct current when this semiconductor are connected to a cell or battery. Means when semiconductor connected to a cell or battery means when we supply some electric field. Means we will make this charge carrier to move in a circuit. So remember this, children, in case of semiconductor, the charge carrier which conduct electricity are not only electron. The charge carrier conduct in semiconductor are electrons as well as hole. Whereas in case of conductor, the only charge carrier in conductor are what? Free electrons. Now even what happened when the temperature of the semiconductor increases? Now if the temperature of the semiconductor rises, then what happened? What you will observe in the same valence band and conduction band, more and more electrons cross over to the conduction band. Okay, more and more electron in the valence band acquire additional energy, thermal energy, due to the rise in temperature, and due to that what happened, that electrons from valence band move to the which band? Conduction band. So when number of more and more electrons cross from valence band to conduction band, equal number of holes that will be left behind in the which band? Valence band. That's why more and more electrons cross over to the conduction band, leaving behind equal number of holes in the valence band. So in order to increase the number of electrons in the conduction band, so what you need to do, increase out here, you have to increase the temperature. So if you increase the temperature, more and more electron from valence band can take to the which band? Conduction band. And due to this, what happened? The conductivity of semiconductor usually increases with the increase in temperature. So conductivity of semiconductor can be increases with the increase in what? Temperature. Okay. So children, in every semiconductor, the charge carrier which provide current, to flow in the semiconductor is actually due to the flow of the electrons and the hole. Because the same semiconductor, if you connect it with the cell or battery which supply electric field, then electrons in the conduction band and holes in the valence band, they move in the opposite direction. So when they move, then the movement of these electrons in the conduction band and holes in the valence band conduct electricity. That means they conduct current. That's why. So what are the charge carrier present in the semiconductor? Electrons as well as what? Holes. Now this is the basic of the semiconductor, where the charge carrier takes place in the semiconductor are due to two charge carrier. One is called electron as well as hole. Now we are going to learn in detail about the types of semiconductor. And this type of semiconductor is on the basis of conductivity of semiconductor, and we classify that semiconductor into two types. One is intrinsic, another is extrinsic semiconductor. And the type of this semiconductor we will be learning in the next YouTube video.